So using interfaces, well, we're definitely going to be programming to an interface. Just plainly using interfaces to solve our issue is not really going to do it. And I'll explain here why. So, like what we can see here, if we try to take our quack and fly behavior and create a quackable and flyable interface, and then use that interface in the objects that need it, it is definitely a cleaner way to have some classes fly, some quack, and some do both. However, it raises a whole new issue here because, for example, our fly behavior now cannot, because interface can't hold any implementation. So each one of the classes will have to implement fly behavior, and that could definitely mean a lot of same code. So it really kills our code reuse. Like, for example, in our abstract class here, we could actually have a fly method that could do the flying, for all of the ducks. So while it solves an issue of creating a cleaner way to have some classes do certain behavior, it introduces whole another issue. And to add to that, the constant in software development is change. So we know that these behaviors might be changing, so that means that we'll constantly have to keep digging into each one of our classes and making changes to our fly, quack, or what else behavior. And that's definitely not a way to go. So to tackle this problem, we'll think of the first design principle that we'll mention here. And this design principle states to identify the aspects of your application that vary and separate them from what remains the same. So this is a very simple principle, and it creates a basis for most of the other patterns. So basically the idea is to take the parts that vary and encapsulate them, so later we can alter or extend these parts on their own. And something that kind of immediately in some of the experience that I've done, this is kind of raises the whole idea of having a repository in our application as a separate, kind of removing the close coupling in a sense. So although having a repository doesn't really, it's not a behavior, but it's something that might change. So we kind of took it out, and we made interaction with it through an interface, and even used dependency injection. So in this case, we are going to identify what changes quite a bit as a part of the application that we are building here, for example, which is a duck class. So we are identifying that our flying and quacking behaviors are changing quite a bit. So we'll be pulling those out, like you can see in this image. So pulling the behaviors out, and then we'll create their own components that can be later extended and altered, but won't influence our current code.